Hello, my name is Nicole Carnes here from exactEarth in Cambridge, Ontario, and I'll be your host today. I'd like to start by saying good morning or afternoon to everyone who's joined us today, and we appreciate you giving up your time to join us as we explore Satellite AIS technology. We assume you've joined us because you've heard something about Satellite AIS or exactEarth and would like to learn more about the technology. This webinar is the second of a series of webinars we'll be hosting aimed at educating people about Satellite AIS. So today, the next 30 minutes, will provide insight into some of the terminology associated with Satellite AIS, such as first pass detection, and also discuss the different methods used to collect and process the AIS signals from the ship. Here today with Peggy Browning and Carl Putty. Peggy is our Senior Director of Maritime Products and our resident AIS expert. She'll be guiding you through the details today of AIS processing and first pass detection. Carl is our GIS expert who will be walking you through some demonstrations of our exactAIS data at work to show you some of the maritime applications that are benefiting from advanced levels of first pass detection. So before we begin, just a small favor we ask is that if you have microphones, to please mute them for the duration of the webinar so everyone can hear us clearly. And if you have any questions throughout, please use the chat window to submit them, and we'll reserve a few minutes at the end to try and answer as many as we can. So on that note,
Thanks, Nicole, and good morning, everyone, and welcome again to our second webinar as we take a closer look at Satellite AIS systems and highlight just how exactEarth is truly revolutionizing this technology. First off, we're assuming that the majority of you have some familiarity with Satellite AIS, and hopefully you participated in our first webinar, Introduction to Satellite AIS. In case you missed it, and shore-to-ship communications, ranging in applications from collision avoidance to security. Terrestrial AIS surveillance or monitoring systems have the benefit of continuous coverage and detection rates that approach 100% close into shore. These systems also have the disadvantage of very limited range and a high cost per square mile covered. Satellite AIS addresses both of these disadvantages as it is able to provide complete global coverage as well as a low cost per square mile covered. However, to achieve effective operational use of Satellite AIS data, and since AIS was never originally designed for satellite reception, the capability detect a high percentage of ships via satellite. So exactEarth uses its own global satellite system and its patented advanced Satellite AIS detection technology. This unique technology has been developed to collect, process, distribute, and archive AIS messages received from ships all over the world. With our exactView system, you get the most accurate picture of maritime. What makes our exactView system so successful is our constellation of high-performing satellites. The deployment of a highly effective Satellite AIS constellation capable of excellent detection from space faces many challenges due to the fact that AIS was primarily intended for local sea-level transmission and reception. The saturation of the satellite receiver due to the high amount of AIS message broadcast, particularly in highly dense shipping areas such as the Mediterranean and Baltic Seas, can create a significant technical barrier to developing an accurate picture for maritime domain awareness. Oh, by the way, we'll be covering our constellation in another details on that. So an effective measurement of a Satellite AIS constellation's ability to detect a high percentage of ships is called first pass detection. First pass detection is the ability for a single satellite to maximize reception of AIS position report broadcasts from ships during a single pass in order to satisfy operational maritime requirements. A pass in the satellite's field of view. Each pass is about 10 minutes over a given ship or area of interest. And given that ship populations are not static, it is of paramount importance to maximize the number of ships detected during each and every satellite pass, as it is likely that when another satellite passes, any given ship may have moved into or out of the satellite field of view. So effective first pass detection is impacted by a number of factors, including ship density, AIS message broadcast frequency, and in-band radio frequency interference. Understanding that there are many factors that can impact detection, AIS time slot collisions and satellite receiver saturation, however, are by far the main factors impacting an AIS satellite's first pass detection performance, and the detection methodology has the largest impact on mitigating both message collision and receiver saturation. So let's talk about these different methods. Collision processing. So let's first look at onboard processing. This processing mode essentially decodes AIS messages directly on the satellite, acting exactly like a terrestrial receiver. The received messages are stored on the spacecraft for later downlink to the nearest Earth station. It does not require any special processing and is effective in very low density areas such as the middle of the Pacific Ocean. However, the detection probability is low in areas where the satellite footprint, remember that's about 5,000 kilometers in diameter, when that footprint contains a ship density exceeding about 2,000 ship, it becomes likely that all AIS message slots are being used by more than one ship at a time. The effect results in a time slot collision, and it becomes dense areas is much lower than spectrum decollision processing over the same area. OBP suffers this poor detection performance partially because of its inability to deal with these time slot collisions in the AIS system when received from space. With a low per pass probability of detection across high-density ship populations, effective operational capability is seldom achieved with satellite AIS onboard processing alone. Spectrum decollision processing is the other method of detection, as it requires the capture of the entire AIS RF spectrum and processing of that spectrum data using highly specialized algorithms to successfully decollide all the AIS messages. With spectrum decollision processing, the first pass detection ability is high even within those high ship density areas, providing a quick and effective operational maritime capability. Statistical analysis has shown that the improvement in first pass detection for this detection methodology is in highly dense shipping areas can result in significantly higher ship detection. Number of position reports received, and that's for behavioral modeling and predictive algorithms, and the reception of multi-part or multi-slot messages containing static and voyage-related information. If the area of interest contains high ship densities, spectrum decollision processing is required to achieve of maritime traffic. Here's another way to look at the difference between onboard processing and spectrum decollision processing. Imagine you are sitting above a huge dining hall, trying to eavesdrop on all the conversations happening below. Hundreds of people are talking at once, so you can imagine the noise of all these conversations blending together. If you were working like an OB voice and conversation from the noise by listening, trying to identify who said what, writing everything down as fast as you can, which is nearly impossible. Using this method, you're going to miss a lot of information. But if you had a special listening device that worked just like spectrum decollision processing satellite, you could sweep up all the noise, send it back to a voice recognition system, which would extract every individual conversation. So all this sounds great, right? But what does it actually mean for the activities and applications facing maritime authorities every day? Let's look at that. I'd like to hand things to benefit from advanced levels of first pass detection. Carl?
Thanks, Peggy. First pass detection benefits a number of important applications. In this webinar, we will look further in depth at the fusion of optical and radar imagery with satellite AIS, search and rescue operations, and how first pass detection plays a major role here. Finally, we will look at environmental and safety forensics and what first-pass detection can do for these types of sensitive. For radar and optical imagery, they both give authorities a live shot of what lies within their maritime domain. Radar imagery for large ships will always give virtually a 100% detection rate, no matter the time of day or weather conditions, whereas optical imagery provides near 100% as long as the image is acquired during the daytime and is essentially in cloud-free and sunny weather. Spectrum decollision processes of satellite AIS data guarantees the maximum first-pass yield for ship detection. So when combining these acquisition methods, the fusion between AIS and radar or optical imagery can be very precise for looking at the maritime domain. Depending on the time of the image acquired and the most recent satellite AIS acquisition, we're required to forecast or hindcast the satellite AIS data to match up with the radar or optical acquisition. After matching this up, we can then go in and identify ships based on physical characteristics, like the size or the look of the ship if you're looking at optical imagery, and the course over ground and the speed the ship is traveling at. This allows us to quickly identify potential dark targets in the data or eliminate the unknown ships from the known. Identification of oil spill culprits. As radar is active, it can always analyze the Earth's surface and ocean, ultimately identifying an oil spill at any time of the day. We can use our historical data and or algorithms that exactEarth has created to forecast and hindcast the data in order to eliminate vessels from being questioned and potentially identify the offender of the oil spill pollution incident. If you were with us in the last webinar, you would have seen us fuse radar imagery with satellite AIS. Here we have an image courtesy of Digital Globe. We will look at fusing the optical image with our satellite AIS. The image is of the boats that we have seen that are very small and characteristic of boats less than 15 meters, possibly go-fast boats or personal pleasure crafts. So the yellow and green ships have been forecasted to the time of the image using exactEarth algorithms and matched up with the particular vessel corresponding to the Digital Globe image. We haven't done this real time as it takes a little bit of processing time, so we've just left the result in front of you. Image, you wouldn't be able to see this as clearly because the pixels are much larger. So we can actually see physical characteristics of the ship and the shape. Now let's just measure the ship. by Satellite AIS as we zoom targets we have not picked up, and we can alert authorities that these vessels may be the target to look at because their AIS may be switched off. As we're in a busy area like Mumbai, there are many small personal vessels moving around too. However, the more vessels there are, the more chance for hazard comes into play, whether it be collisions or transshipping. Satellite AIS is also a very important tool for search and rescue efforts. It enables authorities to identify ships within the proximity of distress situations, like drifting vessels at sea. Satellite AIS can enhance planning efficiency for both routine investigations and in emergency circumstances. Where first pass detection steps in is the ability for authorities to quickly identify the majority of ships within a proximity of a vessel in distress and take action to contact these vessels and coordinate a rescue operation. Satellite AIS data was used by the Australian Maritime Safety Authority to save a man's life. Australia is a country with an extremely large maritime search and rescue region. Waters around Australia can be very treacherous for ships to navigate. As a result, AMSA constantly has to be on the lookout for vessels in distress. This example takes us back a couple months ago to January 18th of 2013, where a lone French sailor's vessel was capsized by the waves and he was left stranded on an emergency raft at sea. That's the yellow boundary you see here. In red, we see the last known position of all the vessels in the area on January 18th. Shows us the approximate location of the sailor. Now, the teal ships you see just sort of beside that are the vessels that were at the time closest to the sailor in distress. So AMSA tried to contact each of the vessels in teal, but no response was received. They then had to turn to the Orion, which was the next closest vessel at the time, and coordinate a rescue operation with the captain and crew. We will now turn on the So we see a large diversion of the Orion had to make to rescue the sailor. We're starting their Antarctic tour on about the 16th of January, and they moved west, southern across the Antarctic to the 17th, and then on they ended up rescuing the sailor about 53 hours later and taking him to the port of Hobart on the Australian island of Tasmania. To protect offshore areas and reduce the risk of maritime casualty and the resulting marine pollution, vessels may be prohibited from entering certain sea areas. Other areas may be tightly controlled due to ecological disasters or to allow endangered marine species the chance to recover. Satellite AIS provides accurate information on ship behavior and position so that it is possible to determine or conclude offenses such as route violations, pollution violations, or irresponsible navigation. Marine parks and protected areas benefit highly from first-pass detection, as spectrum decollision processing maximizes the probability that almost all ships in the area will be identified and authorities can quickly investigate the incident. The number of position reports is critical when looking at patterns in marine protected areas because it will reveal a ship's more particular route or the time that it spent in an area of interest. This allows authorities to an area of the South Pacific Ocean that has a large amount of marine ecology and an area that has seen its fair share of marine disasters caused from shipping in the past. Again, we're in Esri's ArcMap platform and are looking at a few marine parks and benthic regions around New Zealand. Here, we have buffered these regions by about 20 nautical miles, so the dark purple line you see is the inner boundary, and the pink or lighter purple line you see is the 20 nautical mile buffer. I've turned on a live WMS web map service of all the vessels in the area, so we get a clear, near real-time picture of the whereabouts of the vessels in relation to these zones. A Panama cargo ship. Colored ships represent fishing vessels. The green represent cargo. The dark blue are tankers, and the red are small vessels, or Class B. Benthic zones require vessels to call in real time to the authorities and ask permission to fish. New Zealand fishing vessel. So likely they have contacted the authorities so that they can get permission to go and fish. The Mare Phoenicium from Gibraltar, actually. So the Jeppesen Maersk actually went in, and it looks like it made a brief stop and continued onwards out. These ships have a lot of position reports, so we can see almost exactly what route each ship took. In a case like this, if there was a pollution scenario, this would allow us to clearly decipher a discrepancy, let's say if there was pollution in the marine protected area. We could rule out that and as you can see, it continued up and out through the other region. Of today's webinar, I've taken you through fusing optical imagery with satellite AIS for suspicious vessel identification, to looking at how first-pass detection has helped save lives with the Australian Maritime Safety Authority's rescue coordination. We have also seen how first-pass detection gives immediate insight into who's nearing or moving amongst some of the ocean's most environmentally sensitive zones. With satellite AIS data, we can confidently decipher vessels' paths among these areas and narrow down culprits of pollution. Anyways, that's a wrap for the demo side of things. I will now hand you back over to our AIS expert, Peggy.
Thanks, Carl. That was great. I think we now have a better understanding of just how important first-pass detection is to a number of maritime operational activities. Satellite AIS is an emerging technology that provides advantages across a wide variety of applications. However, without the high rates of first-pass detection provided by spectrum decollision processing, these applications are limited to a smaller sampling of the maritime traffic rather than providing a more complete picture. After an in-depth comparison analysis, onboard processing is adequate in low-density shipping areas of the world, but as the number of ships utilizing AIS continues to increase, those areas will become increasingly rare. Operational first-pass detection must maximize the number of ships detected during each and every pass, and only through spectrum decollision processing can the constellation effectively increase the reception levels for all AIS messages. First-pass detection using spectrum decollision processing provides a complete and comprehensive view into shipping activity across the globe, regardless of ship density, and proves to be the critical enabler for achieving true maritime domain awareness. So on that note, I think we'll
Thanks, Peggy. We did have a few questions come in during the webinar, so we'll try to answer them quickly now. We do apologize if we can't get to your question, but we will respond to you all shortly by email. So Peggy, our first question came in. It asked, can SDP be done by anyone?
No, spectrum decollision processing and the algorithms required for it are all patented by exactEarth, so it is our claim to fame.
Okay, great. And the second question asked, what are the most difficult areas in the world for detection?
Oh, there's several of them, and none of them will be a surprise. The Mediterranean, Baltic, Malacca Straits, China Sea, Gulf of Mexico, these are all some of the areas where the ship density is so high that meaningful first-pass detection can only be achieved with spectrum decollision processing.
At this point, and we do want to thank you all for taking the time to learn about first-pass detection with us here at exactEarth. Don't forget, we'll be running a series of webinars on various satellite AIS topics, so be sure to visit our website for more information, www.exactearth.com. Thanks, everybody.
Thank you. Please stand by.